Today's lesson is on rewriting radicals in exponential form. As usual, there is a video guide to go along with this video. If you haven't printed it already, go ahead and pause the video, print the video guide, and then come back. That way you can fill out the worksheet with me and do the examples with me at the same time. So today we're talking about taking something that's in radical form and putting it into exponential form. So before we actually get started and do some examples with that, let's go ahead and go over some terms that you should already know. If you are not comfortable with them yet, that's okay. We're going to talk about the actual definitions together. So first one is an exponent, okay? We've used exponents before. We've talked about exponents when we did order of operations. All right, but let's, again, just review it, make sure that you remember what an exponent is. So an exponent is just the small number in the top right corner of another number. Okay, so that's where it's located, small number to the top right. All right, and it tells you how many times to multiply a number by itself. So it's a small number in the top right corner that tells you how many times to multiply a number by itself. Okay, so if we think of just an example of that, we could do like 5 to the third power, okay? That's telling us that if the exponent is 3, we are supposed to multiply 5, the large number, by itself 3 times. So that's the same thing as saying 5 times 5 times 5, okay? And again, we've talked about exponents before, and we actually did a whole section on exponents. All right, our next word is probably a little different for you, one that you haven't heard as often. It's the word radical. All right, the math definition for the word radical is different from just our usual use of that word. So a radical is actually another term for the square root symbol, okay? So radical is just that square root symbol. But it's a more general term than just saying square root. So it looks like this. All right, that's what the radical is. But we don't just use radicals for just square roots. That's the most common one. So when we talk about square roots, if I asked you maybe like the square root of 49, I'm asking you what number times itself would give you 49. So the answer would be 7, because 7 times itself gives you 49. So we're kind of undoing exponents with radicals, all right? But there's more than just square roots, okay? There's cubed roots. So if there was a 3 out in front, a very small 3 out in front of the root, that would be a cubed root. There could be a 4th root, so that would be if there's a 4 out in front. 5th root, 6th root, 7th root, I think you get the idea, okay? You can put any number out front here. And that tells you how many times that smaller number, the answer, should be multiplied by itself to get what's inside. So just as a quick example, if I said, let's do the 3rd root of 27, I'm asking what number times itself will give you 27. But I have to multiply that number by itself 3 times. All right, a square root, you only have to multiply it by itself 2 times. But a cubed root, you have to multiply it by itself 3 times. So answer for this one is actually 3, because if I multiply 3 by itself 3 times 3 is 9, times 3 is 27, 3 different times, I would get the number underneath the radical, okay? So there are different roots. Square root is the most common, all right? That's the one we use the most often, but there are many other roots, okay? Infinitely many roots, actually. You can change that number out front. Okay, so that's something that you'll want to keep in mind, that the small number the small number outside the radical. Outside the radical represents the root. Okay, so the small number will tell you how many times you're supposed to multiply the number by itself. Okay? For square roots, it's 2. They don't put the 2, but it is there. It's just understood that it's a square root if they don't put a number. Okay? So that's something also important to remember. Last but not least, we're going to go over the term rational number. Again, this might be one that you've heard, but maybe not very often. A rational number is just any number that can be written as a fraction. And the reason why we're talking about that is because when we rewrite radicals into exponential form, we're actually going to be writing them as fractions, okay? Another term for that is we're going to write them as rational numbers, okay? So if you see that word rational number, or they say your answer has to be in rational form, they're just talking about fraction, okay? They're saying that they want your answer written as a fraction or something that can be written as a fraction. So like 1/2, 3/4. 5 is a rational number because any whole number can be written as a fraction with a denominator of 1. So even though I didn't say the denominator, I don't write the denominator, it's there, it's just assumed that it's 1, okay? So they don't put that in. So here's the two that we need to pay attention to, the numerator and the denominator of our rational numbers, our fractions, okay? For the numerator, when we rewrite these, the numerator represents the exponent in the problem, okay? So look for the exponent in the problem. That's going to be the numerator of our fraction, okay? So the numerator of the fraction is going to be the exponent that they give us. The denominator represents the radical, okay? And remember, the radical has those small numbers out front that tell you the root, okay? That root, that radical number is going to be our denominator when we rewrite these in exponential form, okay? So these two things you really need to remember. The numerator represents the exponent, so that'll go at the top of our fraction. The denominator represents the radical, so that number will go at the bottom of our fraction. And we'll go ahead and do a few examples of these together. So let's take a look at problem number 1. We have the 5th root of x to the 2nd power. All we're doing for this lesson is rewriting this problem, this radical, in exponential form. And that means my exponent is going to be a rational number or a fraction, okay? That's all I want to do. Write it as that fraction, all right? Your letter is going to stay the same, okay? We have x. X is going to be our letter in our answer, so I'm going to put x. Our exponent is, again, going to be a fraction, and we said the numerator is the exponent, the denominator is the radical. So looking at this problem, this is x to the 2nd power. 2 is the exponent, so that means 2 is going to go at the top of my fraction. After that, we need the denominator. The denominator is always the radical, the number, the small number outside the radical sign. So that small 5, that's going to be our denominator. So we have 2/5, x to the 2/5. That's our fraction. The only thing that you need to do at this point is to then check your fraction and see if there's a common number that you can divide them both by, so you can simplify the fraction. But 2/5, 2 is only divisible by itself, 5 is only divisible by itself, so this cannot be simplified. So x to the 2/5 is our answer for problem number 1. Again, all we're doing is rewriting these. In later lessons, we'll learn how to use this and how it's going to apply to actually working out a problem. But right now, I just want you to learn how to rewrite radicals in exponential form. So let's take a look at problem number 2. We have the 7th root of m. Well, m is going to stay the same, and then my exponent is going to be a fraction. Now, first thing we need is the numerator, and the numerator is the exponent in this problem. But you'll notice there is no exponent. That's okay. Remember, every letter, every number has an exponent, whether it's written or not. The missing exponent is always 1. Okay? So in this case, this is m to the first power. They just didn't write it. So that means my numerator for my fraction is going to be 1. The denominator is the radical, the root. Okay, so looking outside of my radical symbol, we have a small 7. That 7 is the denominator. So my exponent is 1/7. Last thing you need to check, can you simplify 1/7? Well, anytime you have 1 in a fraction, it can't be simplified. So 1/7 is going to be the exponent for number 2. Next one, number 3, we have the 4th root of d to the 14th power. Okay, so d stays the same. My exponent is going to be a fraction, a rational number. The numerator of that fraction is going to be the exponent in the original problem. Okay, the exponent in the original problem is 14, so my numerator is going to be 14. The denominator is the radical. Okay, so my radical here is 4, so my denominator is going to be 4. So I have d to the 14/4. Now, I need to check and see if I can simplify this. Looking at these two problems, 14 and 4, they're both even numbers, which means they are both divisible by 2. So I can simplify this, so I need to simplify it. I can divide top and bottom by 2, which gives me 14 divided by 2 is 7, and 4 divided by 2 is 2. So I have d to the 7 halves. That is my exponent in simplest form. Again, if you can simplify it, do. If you can't, then you just leave it. For problem number 4, we have the square root of k to the 3rd power. All right, so I want to rewrite this in exponential form. So I'm going to start with my k, and I know my exponent is going to be a fraction, so I'll go ahead and put the fraction bar. We need to start with the numerator. The numerator is the exponent in the original problem. So looking at this, my exponent is 3, so my numerator is going to be 3. Now for this one, I don't have a number outside of the radical symbol. And we talked about this a little bit. Anytime there is no number outside of the radical, that means it's a square root, okay? A square root means there's actually a 2 out here, but they don't write it. So this is where it gets a little tricky because we're so used to thinking, well, if no number is written in, then there's a 1, it's just not there. But for square roots, it's a little bit different, okay? They're actually looking for how many times it multiplies by itself, okay? 2 times, okay? So that means 2 is actually outside, they just didn't write it in, okay? So this is the only case where it's different. All right, so you'll have to remember that. That's a little bit tricky. All right, so there is a 2 out front, it's just not written in, which means my denominator will be 2. So I have k to the 3 halves. From there, all right, we need to determine if we can simplify this or not. 3 and 2. 3 is only divisible by itself. 2 is only divisible by itself. There's no common divisor there, so k to the 3 halves is my answer for problem number 4. For problem number 5, we have the 9th root of h to the 15th power. So our h is going to stay the same. And then we know the exponent is going to be a fraction, so I'll go ahead and put my fraction bar. From there, we need to know the numerator is the exponent. So looking at our problem, the exponent is 15, so 15 is my numerator. The denominator is the radical or the root. Okay, this is the 9th root, so 9 is my denominator. So I have h to the 15 ninths. Now at this point, we need to determine, can we simplify this or not? All right, looking at 15 and 9, I can see that both of them are divisible by 3. So I'm going to divide top and bottom by 3. So 15 divided by 3 is 5. 9 divided by 3 is 3. So that means if I can't simplify this 5 and 3, which I can't, okay? 5 and 3, there's no common divisor there. So h stays the same, and my exponent is going to be 5/3 for problem number 5. All right, and last one we're going to do together, number 6. We have the 12th root of w to the 6th power. All right, start with your w. We're going to write our exponent as a fraction. Remember, exponent at the top, radical at the bottom. So my exponent here is a 6, so 6 goes at the top. 12 is my radical, my root, so that goes in the denominator. So I have w to the 6/12. From there we have to determine, can we simplify? The answer is yes. 6 and 12 do have a common divisor. Now you can start out with something simple like 2 because they're both even, or you could start out with 3 because they're both divisible by 3, but there is a larger number, okay? 6 and 12 are both divisible by 6, so that's what I'm going to go with. I'm going to divide the top and bottom by 6. So 6 divided by 6 is 1, and 12 divided by 6 is 2. So my exponent is 1/2, and I can't simplify that any further. So my answer is w to the 1/2 power. Now, before you do problem 7 and 8 on your own, I do want to talk about, just really quick, notice that any of the exponents that I have, if they are an improper fraction, I leave them as an improper fraction, okay? Don't change these into mixed numbers, no mixed numbers, okay? We have an exponent, we have a radical, keep them separate. Don't make it into a mixed number, so leave these as like 5/3, okay? You don't have to write improper fractions as mixed numbers, all right? So go ahead and try problem 7 and 8 on your own. So pause the video, work out those two problems, and then come back and you can check your work with mine. For problem number 7, we have the 20th root of p to the 6th power. All right, so the first thing I did was make my exponent the numerator of the fraction and my radical the denominator. So I had p to the 6/20ths. And then I noticed that I could simplify this. They're both even, so I can divide them both by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. So my answer is p to the 3/10 power. For problem number 8, we have the 3rd root of j to the 9th power. So I rewrote this as j, and then 9 as my numerator, 3 as my denominator, because exponent for the numerator, radical for the denominator. I noticed that 9 over 3 can be simplified to just 3, okay? If it's divisible, go ahead and just divide it straight out. Now remember, I know that we're writing all of these as fractions, but whole numbers are fractions with a denominator of 1. You just don't have to write that denominator of 1. And they won't, okay, because they're going to simplify all the way. Write it as simply as they can. And 3 is a simpler way of writing it than 3 over 1, so they'll make it just 3. So my answer is just j to the 3rd power. That's it. And that's the end of our lesson on rewriting radicals in exponential form.